Pre-Algebra, Mr. Lawrence here with a flipped lesson for Monday, May 7th. And we talked in class today about the SO part of SOHCAHTOA, and we were going to review that. All right, remember that the S stands for the sign. On your calculator, it looks like the SIN button, the sin button. Please do not tell your parents I'm teaching about sin. Nothing could be further from the truth. I'm teaching about the sign, and the sign is a ratio of a right triangle. The sign is equal to the ratio of the opposite side over the hypotenuse. All right. So that is sine of an angle is equal to the opposite side over the hypotenuse. So if I have a right triangle, like so, and I tell you that this is the right angle, and that'll be C, and that'll be A, and that'll be B, and I give you some of this information, you can figure out missing pieces of this triangle. For example, if I wanted to know the measure of side X, and I knew that this side, the hypotenuse was 25, say, centimeters, and I also knew that measure of angle A was 30 degrees. Okay, I can figure out the measure of X. Normally, to do the Pythagorean theorem, you'd have to have two of those three sides to be able to figure out the missing side. Now, if you know the measure of one of the non-right angles, you can do it. So, notice that I'm going to take the sine of the angle, the sine of 30 degrees. I know you don't know what that means. That's okay. Your calculator will take care of that part for you. It's a ratio. Some people a long time ago figured out some ratios with triangles, right triangles. They wrote them all down. They passed them on. All right. Now, this equals the fraction. The opposite side, well, first let me highlight my hypotenuse. Shoop. All right. Now, my opposite side is the side across from it. So I need to write a fraction of the opposite side, in this case X, over the hypotenuse, 25. And I'm going to remember it's centimeters, all right? I can put that over 1 and cross multiply. So I'm going to get 25 times the sine of 30 degrees, and that's going to equal X. And here's where I go to my calculator. Hold on one second. Okay, so I believe I had 25 times the sine of 30 degrees. And, oh, you know what? I have to change a setting. Please make sure your calculator is in degrees and not radians. On mine, it's here. If you're not sure how to do that, you can ask me in class. Make sure you set up your fraction, though. All right, there we go. Now, let me try it again. And let me do second enter. And there we go. I get 12.5 for a measurement. That looks a lot better. So what that means is that X ends up equaling 12.5 centimeters. All right? That's how simple it is. If I have a right triangle like this, let me see, get my right triangle there, and let me make it look different. Okay, I'll put my right angle where it goes. I'll call that C, I'll call that A, and that B. And this time I don't know the hypotenuse, and I know that this is a 50-degree angle, and I know the side across from it, opposite it, is going to be, say, not 10, I used 10 too much. Let's make it 14 inches. All right, again, I'm going to highlight my hypotenuse. I know that the side opposite is involved and the hypotenuse. Well, sine uses the opposite side over the hypotenuse. So I'm going to take the sine of 50 degrees, and I'm going to put that 14 over X. All right, and I'm going to cross multiply, and I'm going to get X times the sine of 50, and that's going to equal 14. Now, X is not alone. What's keeping it from being alone? The sine of 50. Sine of 50. So I'm going to divide each side by the sine of 50 degrees. These will cancel. I'll have x equals 14 divided by the sine of 50 degrees. And I can go to my calculator and type in 14 divided by the sine of 50 degrees. And there we go. If I'm rounding to the nearest tenth like it is on the homework, I'll have 18.3 inches. So x will equal 18.3 inches. That's it. It's a piece of cake. It really is simple. Now what you're going to do in class Tuesday is you're going to use your right triangle, your SO, to figure out the measure of an angle. This is something we could not do with Pythagoras at all. Pythagoras could not do this. All right. Let's say this is, I don't want to make it 60 degrees. Let's say this is theta. What's theta? It's a Greek letter, and they just use it for angles. Okay, you know, we use x for variables for sides. Well, for angles, they use theta quite often. All right, and I'm going to tell you that this is 30 centimeters, and this one here is 15 centimeters. All right, so I see what two sides I have involved. There's my hypotenuse, and the 30 or the 15 is opposite of theta. This is a sine problem. I'm going to do the sine of an angle. It's going to be equal to the opposite side over the hypotenuse. All right, well, I'm going to do the sine. I don't know what I'm doing the sine of. Yes, I do. It's theta, the angle. It's a little circle with a little squiggly thing in there. All right, and I'm going to write the fraction the opposite side, 15 over 30. So I'm going to simplify this fraction. I'm going to get the sine of theta is going to equal 1/2. Now, how do I get that theta alone? That's not multiplication going on. I do have to use the inverse operation, and what I'm going to do of each side is I'm going to take what's called the inverse sine. So theta is going to be equal to the inverse sine of 1/2. Okay, so I'm going to take the inverse sine. That's right here. Take inverse sine. Whenever we're doing these trigonometric functions and we don't know the angle, we'll do the inverse sine. So let me come over here and let me go. If you notice your sine button in yellow or blue, if you hit the second key, you get an inverse sine. I have 1 divided by 2, 1/2. And look at that, my angle is 30 degrees. That's pretty powerful stuff. So that means theta would be a 30-degree angle. Let's try one more. All right, we'll do a theta again. So let me have a right triangle here. And I'll change its orientation just so it looks different. There we go. And I will put the right angle in where it goes. C, A, and B. And I will call my hypotenuse, say, 40. And I will call this side, I don't know, 15. And then theta will be angle A. All right. So I'm going to try to figure out the measure of angle A. Well, again, where's my hypotenuse? There it is. Okay. And what side am I dealing with? I look at my angle and I go to the side opposite. So I'm dealing with a sine problem. I'm going to do the sine. The sine of what? I don't know. Theta. That's going to equal 15 over 40. All right. I can simplify that fraction. Looks like it's going to be 3/8. All right. So I'm going to take the inverse sine of both sides. So then theta is going to equal the inverse sine of 3/8. I go to my calculator at this point. Clear that out of the way. I'm going to do second sine, and I'm going to do 3 divided by 8. Hit enter, and there we go. It looks like it's a 22-degree angle rounded to the nearest 10. So theta is going to equal about, in fact, I could do the wavy line thingy, 22 degrees. It's that simple, ladies and gentlemen. Don't worry, we're going to get some good practice with this over the next few days. All right, that's your flipped lesson for tonight. Mr. Lawrence signing off. Good night, everybody.